Hey guys, welcome back to Pymunk Basics. So in this video, we'll talk all things collision. So everything we need to know about colliding objects and get us going on how to simulate colliding objects will be in this video. So right now, I just have a basic setup that I've showed you guys in the Pymunk Basics, integrating Pymunk and Pygame video. And this essentially just gives me a screen and a Pymunk space that matches the screen. So let's start writing some objects onto this screen. And like we talked about in the previous video, every time I create an object, I like to create a class for them. So I'm going to create a class called ball. I'm going to define an init. And what goes in the init argument, it's going to be whatever instance is going to be, whatever is going to be different among each instance of the ball. So if we create multiple balls that I want to bring in when I create that instance. So for now, we'll do an X and Y. We'll do a different X and Y for each ball that we create. And things we do within the init is we create an attribute called body, and this is going to be our Pymunk body. We know how to do this. An attribute called shape. And actually, before I do that, let's just go ahead and set the body's position. And what do you guys think the body's position is going to be? Yep, X, Y. And we'll set the shape as Pymunk dot shape. Sorry, Pymunk dot circle. We don't want to ever start shape by itself. We want to attach the body. Geez, sorry for the typos. I got a new computer, so it's kind of hard to get used to typing on it. And so I'm going to create a radius of 10 for the shape. And we'll create a shape's elasticity. And I'll create that as 1. And we also want a shape's density. Density also as 1. Now, what else do we need to do here? We need to create a draw class. So define draw, bring in self. Sorry, not draw class. That'll be a draw method. And I can say pygame dot draw dot circle. And I forgot what goes in this argument. So let's go find out. Pygame circle. So pygame dot draw dot circle is going to be surface, color, center, and radius. So surface is our display. Color, what do you guys want to do? Let's do like red. So 255, 0, and center. And so we're going to have to unpack here equals self.body.position so we can make it integers. Position, or better yet, we're going to have to create a function called convert coordinates like we did before. So a lot of this I'm going through fast because I've talked about in previous videos. So I'm going to say points, and I'll return the integer of 0.1. And this way, this kind of handles the integer conversion already for us. We don't have to do this down here. And then we have a 600 by 600 pixels is going to be our display. So this will be 600 minus integer of 0.1. So this will be X and Y. By doing this, I can actually just go ahead right here and say convert coordinates and put in self.body.position. And yeah, this is getting kind of long. And what was the last thing? The radius I said 10. And of course, since we've said the radius in two different places, it would make a lot of sense for us to want to undefined name point. It would make a lot of sense for us to have a variable up here called ball radius. And so we don't have to keep writing this twice, but I'll let you guys figure out how to handle that situation. So for now, I think we are good to start creating instances of the ball. So I'll just create one for now. So ball equals ball, and then I'll put it at 100. And then remember, the next thing we have to do is first we have to fill the display. So let's display.fill. Let's do white, 255, 255. 255, and this has to be its own tuple. And then we can say ball.draw. Now I'm going to go ahead and run this, and we have drawn the ball at exactly where we'd expect to have drawn the ball. Now let's create a second ball. So I'll say ball2 equals ball, and we'll put it at an X of, let's do 100 again. And this one we'll do, let's say 500. So let's go ahead and, let's draw this first, and we'll go ahead and run this. Ball2 dot draw and go. So now we have two different balls, but they're not moving. So we're going to have to give the balls a velocity, and we'll give it a random velocity. So self.body.velocity. And to do anything random, we're going to have to first import random in Python. And we'll say random.uniform. Remember, uniform gives a random value between two values that don't necessarily have to be integers, and they could be floating point values, and it will return a floating point value. So random uniform between, let's do -100 and 100. And then that's going to be for X velocity. We'll do the same thing for Y velocity. So now let's go ahead and run this. And we're not moving. So I made the classic mistake that I've told you guys plenty of times not to make, is I never added either of these to the space. So it's self.body, and then I need to add self.shape. Now let's run. And we're moving really, really slow. So let's definitely change this up a little bit. Maybe 400, 400, 400, and 400. Where are we at? That's pretty fast, but that's okay. Now is a good time to start talking about collision. So in Pymunk, the way we handle collisions is through what's called a collision handler, and that'll give us all the information that we want to know about our collisions. So let's go ahead and start a collision handler. Handler equals space.add collision handler. And I think now is a good time to start reviewing the documentation on what collision handlers are. So we'll go ahead and go straight to our collision handler object, but the space.add collision handler, all it's doing is creating this collision handler object. So we'll read some of the documentation. This is actually the source code, but it has a lot of good documentation on here, and I will link this into the description. So a collision handler is a set of four function callbacks for the different collision events that Pymunk recognizes. So what that means is the different collision events, there are 4 of them. So they are, as they list over here, begin, separate, then there's pre-solve and post-solve. So let's go ahead and look at some of these. So we'll talk about begin. Begin is when two shapes just start touching each other for the first time. So you have two shapes, they just start touching each other. This expects an space arbiter data, or I guess an arbiter space data, arguments to this function. So we set this begin attribute of the collision handler with a function that has the argument arbiter space data, I keep saying in the wrong order, but the order really doesn't matter, and is expected to return a Boolean. So return true from the callback to process the collision normally. So if you want, when these two objects to collide, to process the collision as the physics should recommend, then you want to return true. But if you want to return false, if you want the collision to be ignored completely. So that's when begin. Begin is when two shapes just start touching each other for the first time. Now there's pre-solve, which is after begin, and it's right before the collision information is calculated. So you have two shapes are touching right before the collision information is calculated. Same thing, it needs an arbiter, space, and data. We'll talk about the arbiter, space, and data in a second, but it needs an arbiter, space, and data. It returns a Boolean, which is a true or false. Same thing, false to make Pymunk ignore the collision, true to make it continue. Here's your chance, though, to override values using the arbiter friction, arbiter elasticity, etc., etc. So you can probably already understand what the arbiter is, but the arbiter is and let's go ahead and look at it, Pymunk arbiter. That is definitely not it. Okay, here we go. So the arbiter is an object that encapsulates a pair of colliding shapes. So every time we want two colliding shapes to collide, or every time we create a collision handler for them, which means look out for these collisions, then we're going to create this arbiter object that just handles all the data behind the scenes. It's created when it starts, and it persists until the shapes are no longer colliding. So what this object allows you to do is set certain things about this collision in particular, like its elasticity or its surface velocity, which essentially means how fast should the surface seem like it's moving. So if you're on like a conveyor belt or a treadmill, there's going to be a set surface velocity, and so on and so forth. So that's our arbiter, and within pre-solve is our chance to use it. So the difference between begin is when the objects first touch. Pre-solve is when the objects are touching already and the collision information is about to be calculated. And when you would use either or is when You want to change some things about the arbiter is when you would use pre-solve. Otherwise, you can just use begin, and that'll be like a frame faster, maybe. And post-solve is going to be after they're touching each other. So if you want to know things about the collision impulse or the kinetic energy, let's say you want to make a sound that's as loud as the collision was. So you can set things like the densities of the objects, and if two really dense objects, really heavy objects collide, then they're going to be a lot of kinetic energy, assuming that they're at very fast speeds. Then you want that to be a louder sound. Well, you can retrieve that information in post-solve. So after the shapes are touching each other, and then you can take care of whatever you're trying to do with that. Biggest difference here, again, it wants the arbiter. It needs the arbiter. Space, the space which you're going to be doing all of this in. And then data is something that we could use to pass along data. We'll talk about that later as well. But what we can use post-solve for is after the shapes are touching. But the biggest difference here is that we don't need to return a Boolean because we've already calculated the collision data and applied it. Now, the last one is separate. So separate are two shapes have just stopped touching for the first time. So when is it important to use separate versus post-solve? Well, if you set false to the begin or to pre-solve, then you're not going to have that pre-solve or post-solve information. And so let's say you don't want collision to be calculated. So you have, let's say, a straight line. And that's like the goal of a soccer game. So you want the ball to go straight through the goal. So you don't want collision to be calculated. Otherwise, it's going to hit off the segment and bounce off. So you'll probably say false for begin. However, you still want to do something at separate. I'm not sure what you may want to do at separate because in that scenario, I'd probably do everything begin, like score the goal or whatever. But if you wanted to do something after they're stopped touching, you can't use post-solve. So that's why they have separate in there. So to recap, we have begin when two objects touch each other. We have pre-solve when they're about to be calculated, which is when we can set certain things about how we want the collision to go. We have post-solve, which is right after they've been calculated, where we can get things about kinetic energy or impulse. And then we have separate, which is essentially the same thing as post-solve, but it's when they stop touching. And that's useful especially if we have set false and begin. Last thing I want to say is if we're going to have something like a goal where we never want it to ever contribute to the physics engine, then not only should we say false and begin, we can also tag something as a sensor that they will never generate collisions that get processed. So if you wanted something to generate collisions sometimes, then I wouldn't say this. But if you wanted to never generate collisions, then say sensor is equal to true, and that'll save you some calculation in the back end of Pymunk because it never has to calculate whether the collision needs to happen or not. So I know that was a lot. It really just only makes sense when you start using it. So let's start using it. So we say handler space add collision handler. So now we've created a collision object called handler. And the other thing I should say, sorry, to flip back and forth is, and I'm not sure if I can actually find this in here. Now it expects two arguments. It expects the ball and ball 2, but it doesn't want this object. Again, this object is a class that we've made up, right? We've made up this. It doesn't want the body either. It doesn't want the shape. It wants what's called a collision identifier. What's the actual word for this? To see what it wants, we can just do this. It wants what's called a collision type. So we have collision type for A, which is the first object, and the collision type for B, which is the second object, which obviously can be interchanged. But really what the collision type is, it's an integer that identifies the object. So let's say I want this to be considered object 1. So ball to be considered object 1 and ball 2 to be considered object 2. Then I need to set its collision type. And I can set its collision type through the space attribute we have here. So not the shape attribute we have here. So it's self.shape.collision type. And let's use the integer 1 or actually, it's going to be different between the two balls. So what are we going to have to do? We're going to have to go collision type as an argument to the init. And I'm just going to say collision type. And then we'll have to bring it in. So this will be 1. This will be 2. And then when I add the collision handler, I can say between object 1 and object 2. Now, what do we want to happen when collision type 1 and 2, which refers to ball and ball 2, actually collide in the Pymunk space, well, we need to give handler a function in either begin, pre-solve, post-solve, or separate, as we saw earlier, to happen during those times. So let's write a function, define collide, I guess. Oops, sorry. Define collide. I don't know what I did here. There we go. Define collide. And I don't need any arguments, or do I need any arguments? Actually, I do. I need an arbiter, a space, and a data. We saw earlier from the documentation that that's what Pymunk expects for each function that's going to be given to the handlers. And you, again, don't really have to worry about exactly what these things are doing behind the scenes, but we have talked about it, right? So let's just do print hello. So it will print hello every time these two objects collide. So we have to figure out, do we want to do it when they begin colliding, after they're done colliding, after they've separated? We can say handler dot separate. And so this will happen when the two objects are done colliding, equals collide. And be careful not to run the function collide here. We don't want to run it here, so we don't want to do that. We want to pass the actual object. In Python, all functions are an object, just like everything, into the handler attribute. So let's go ahead and run this. And once these balls collide, it gives us whatever we want it to do in this function. So that's great. Now, let's kind of make this a little bit more advanced. Let's add a bunch of balls. So a bunch of balls, and we don't want to have to keep calling this this function every single time and kind of rewriting our ball 3, ball 4. So what do you guys think we need to do? We need to do some iteration. So I'll say balls equals a list of balls, right? And we can say, I'm going to use some list comprehension, but if you don't understand list comprehension, there's a lot of tutorials on it, or you can just do it using just a normal for loop. So ball, we're going to create an instance of ball, a bunch of them. Each one will do a random position. So I'll do random dot rand int, because we need a random integer position, between 0 and, how big is the screen? 600. Between 0 and 600. And then a random y position dot rand int between, you guessed it, 0 and 600. And then we need a collision type. I'm going to come back to collision type. And up equals 1, which is not going to be relevant in a minute. We'll see why, but that's okay. We'll leave it at that. So I'm just going to say CT, just so remember for me that I have to remember to come back to this. Now, for I in range, let's, how many balls do we want? Let's do 100. Whoops. So I can get rid of all of these for now. I'm going to show you guys how to handle this in the case of a list of balls. So first, drawing it, we need balls.draw. Can we say that? No, we have to do this in list comprehension again. So ball.draw for ball in balls. Now, what else do we need here? What's the problem? Undefined name CT. So we do need to set a collision type. For now, I'm just going to set collision type to all be 1. Nothing's going to happen when they collide because we haven't set any handlers for it. But I just want to show you that this all works. And all the velocities are going up because that's the default value and that's the default velocity. I'm going to comment that out, and I'm just going to do random velocity. So yeah, they're moving really fast, but they're all colliding, I promise you. Now let's say we wanted this collide function to happen when one of the balls hits any other ball. So I'm going to go ahead and say balls.append and create one more ball. Again, I guess I could just set this position. I don't want to have to write out random again. So I'll set it at 400, 400. It's going to give it a random velocity in its init method. And I'm going to set its collision type as 2. So every ball has a collision type of 1 besides this one. It has a collision type of 2. Then I'm going to say handler equals space dot add collision handler. And I need the 2 collision types, so 1 and 2 again. And we need to say handler dot, let's do separate. Actually, let's do something different. Let's do begin, and let's recognize something. If we're using begin and pre-solve, what do we need? We need a Boolean. So do I want this collision to still process? Sure. We'll say true. Handler.begin, and I can do collide. I need to pass the collide function through here. So undefined name handler. And let me press my insert button right here. This is a new computer, so I actually have no idea where the insert button is on this keyboard. How did I press it a minute ago? That's too bad. So I'll say handler dot begin equals collide. Great, so let's go ahead and run this. And I'm missing one argument. That is right, because I don't know what I did here, but it should be like that. Now let's go ahead and run this. Great. So every time that one ball has collided, and unfortunately we can't actually see it, but we can trust that every time that one ball has collided with any other balls, we've run the collide function. So the last thing we want to do is maybe have that one ball be blue instead of red, and every ball it touches, I want to turn it to be blue. So instead of collide, I want something else to happen. Oh, I found insert on the 0 key. So there we go. So what we need is we need two different things to happen in the draw class. We need to either draw it as red or draw it as blue. So I'll say if collision type, self.shape.collision type, and it could be worth making an attribute or like a property that's collision type, so you don't have to keep typing self.shape.collision type. But for now, for the sake of simplicity of this tutorial, I will keep it at that. So if it's 1, then we're going to draw a red circle, as it is already. And if it is 2, then we can draw it as blue. So 0 here. RGB 255. So I don't know why I got rid of my collide function, but I did. So let's go ahead and recover that. So I think I said define collide, and then we need an arbiter, space, data, and then let's do print hello from the other side this time. Just spice it up a little bit. And then this is begin, so I'm going to need a return, I guess, true, because I do want the collisions to happen. And let's watch the ball quickly. So 1, 2, 3, 4, 5, 6, I guess. I couldn't count as many collisions as they were. But we saw that the one blue ball is the one that we've appended down here because we gave it a collision type of 2, and that's what we asked for in the draw function. So every time this collides, we're getting another hello from the other side. Great. But let's say we want to convert every ball that's been hit to be blue. Now, the thing about that is we need to give this handler.begin a more specific function than just a general global function. We actually need to give it a method. But if we need to give it a method, we also need to give it one more thing. We need to give it which method to run of which of these balls, because each of these balls has their own method, and we don't want to just convert every ball to blue by running everyone's method. So to do that, though, we also need a sense of which ball we are hitting. We can't just have a collision type of 1 be every red ball, and we can't have a collision type of 2 be every blue ball. Well, we actually could, but we can't have and we'll see why in a minute, but we can't have every red ball be a collision type of 1, because if they collide, then we don't know which ball to turn blue. So what we need is not a collision type of 1, but we need a bunch of collision types for all of these. So I'm going to say, so instead of saying I for the collision type, we need to say, let's do I plus 1, 2, 3. So that way everything starts at 3 and goes up to, I guess, 102 would that be? Or 103? 102, because there's 100 of them. Now we have a unique collision type for each red ball, but we have only one collision type for any blue ball, and that's exactly what we want. Anytime a blue ball hits a red ball, that specific red ball needs to run one of its methods. So let's first also change our draw function. That's the first thing we should do. To anything besides 2 should be red. So if self.collision type does not equal 2 is how we're going to change this to. Then we want it to be red. Otherwise, so in Python, otherwise, else, then we want this to be red. And this works out perfectly. Let's run this and make sure. Yeah, there we go. And obviously now there's no 1, so it didn't do the hello from the other side because it never ran collide because there is no collision type 1. So we need not one handler, but we need a different handler for each red ball, and we need to run its method. So let's go ahead and write which method we want to run first before we create a bunch of handlers. So I'll say define change blue, or change to blue, just to be very clear about what I mean by this method. What do we need to change this ball to blue? We need to change its collision type, its shape.collision type to 2. So self.shape got collision type. And again, if you create this as a property, then you could just say self.collision type or self.whatever. And maybe we'll talk about that in a different video if that's not clear to you. But self.shape.collision type equals 2. So now we know we want to run the ball's change to blue method, but we don't know which ball. So we need to create a bunch of handlers. And so I'll say instead of handlers equals, space dot add, and I'm doing this in list comprehension, add collision handler between 2 and I. Let's just to keep it very clear for I in range 100. Yeah, you could do like for I in range 3 to 103, but I'm just going to keep it so it looks exactly the same as here. Again, if you wrote this right, you would do this as 0, and you would do this as I from 1 to whatever, or better yet, you would do this as 101, and then this from I from 0, which is it is to 100. So we can say for handler in handlers, then handler dot separate equals ball index I, and we're gonna have to create an I here. We'll do that in a minute, and it's going to be its change to blue. So we can just use enumerate handlers, just because we know we have exactly the same amount of handlers as we do balls. So for I handler enumerate, I can never say that word, enumerate handlers. So the I is going to be the index of the handler, which is also going to be the index of the relevant ball because we have them matched up. And the handler is going to be the handler itself. We could also have done just for I in range 100 and did handlers of I, but this is the recommended way of doing it in Python. And the problem here is undefined name ball because it's balls. Now we have a different handler for each red ball, and each time that collides with a blue ball, then it's going to run its specific change to blue function. So let's go ahead and run this and see if it works. And it doesn't. That's because I didn't add arbiter space data to the change to blue function, or sorry, the change to blue method. And I want you to do this every time you're doing anything, just getting some cleanliness, anytime you do anything with handlers. And anytime you want to pass a function to one of the handlers, I need you to do arbiter space data as the arguments. So let's go ahead and run this. So now every time a blue ball contacts a red ball, we are changing the color to blue. And I'll run this one more time just for visual. And actually, let me slow down the velocities a little bit. I want to be able to see this a little bit better than that. And let's run it. So yeah, every time a blue ball is hitting a red ball, it's running its handler and it is changing its color to blue. So that's the basics of collision handling in Pymunk. There is a lot more to go into with this, but we've done a lot today. We've talked about the begin, pre-solve, post-solve separate functions, which are the 4 events that Pymunk can give every time there's a collision. We've also talked about how to do this in a larger scale, and we're taking very huge advantage of this object-oriented approach. And all of this happens in just a very small 50-line script. And we've already created a simulation where a bunch of balls are hitting other balls and we're changing colors and we're doing collision data. And there's so much going on here in just this very small script because we've taken advantage of object-oriented programming and we've let Pymunk do the physics behind the scenes. But this is a lot, so feel free to ask questions in the comments. Collision data is probably the hardest to work with when it comes to physics engines and the most confusing, so definitely ask questions.